Now let's look at how to perform arithmetic with binary numbers. So here are some fundamental facts that we need to know. 0 plus 0 is still 0. 0 plus 1 or 1 plus 0 is still 1. So that's pretty straightforward. If I add 1 plus 1 though, I'm going to get 1, 0, because remember this is binary, and this is how we represent 2 in binary. And then 1 plus 1 plus 1 gives me 1, 1, which is 3 in binary. Now if we have larger numbers, we're going to add them the same way we would with decimal numbers. We're going to do one place at a time, working our way from the rightmost place to the left. So for example, if we're adding these two decimal numbers, we would first add the things in the ones column, then the tens column, and notice we're getting a carry bit here because 3 plus 7 is 10, so you put the 0 down here and you carry the 1. That carry bit gets added to the 5 and the 2 to give us 8 for the hundreds digit, then the thousands digit, and here again we're getting a carry because 2 plus 9 is 11, so you put the 1 and you carry the 1, and then finally that carry bit gets added to that final 1 to give us 2. We're going to do the same thing with binary numbers. So when we add the ones place, we get 0 here. Then we go to the twos place. 1 plus 0 is 1. And then this next place, we're getting 1 plus 1, which is 2 in binary, 1, 0. So the 0 goes down here, the 1 gets carried. In the next place, we have 1 plus 1 plus 1, which we said was 1, 1. And again, we're going to have the first 1 here, and then we carry the 1. And then we have 1 plus 0 plus 1, which is 1, 0, and we carry again. And then that final carry bit gets brought down, and we have our final result. To multiply two binary numbers, we're again going to take an approach that is analogous to what we would do for decimal numbers. So first, we're going to take the rightmost digit of the second number and multiply it. And in this case, because it's a 0, we're going to get all zeros. Then the next digit, which is a 1, gets multiplied. And you can see that because it's a 1, we're getting all of those digits the same, but we have to push it in one place, just like you would in the decimal version, right? So you push it in one place, and I'm putting a 0 there to be a placeholder. And then we just keep doing that. Anytime we have a 1, we get the same bits, but pushed over. Anytime we have a 0, we get zeros. And then we're just going to add up all of the columns to get the final result. It's sometimes useful to shift the bits in a binary number. Shifting to the left is going to move every bit one place to the left, and we're going to end up with a 0 in the rightmost place. So let's say we start with this set of 7 bits, this 7-bit binary number. If we do a left shift, all of those 7 bits slide over, and we get an extra 0 in the rightmost place. Now, if you look at what these are in decimal, so these numbers in base 2 are these numbers in base 10, you can see that we've gone from 90 to 180. And so it turns out when you do a left shift by one place, you double the value of the number. Python gives us an operator called the left shift operator that allows us to shift bits to the left. And this is what it looks like. It's two less than symbols right next to each other. And so here, for example, I'm saying take the binary representation of 75 and shift its bits to the left by 1. And I'm going to end up doubling 75 and getting 150. You could also shift by a different number of bits by putting a different number here. You could shift by 2 bits or 3 bits, etc. We can also shift bits to the right, and this time we're going to start with our number. And then, because we're shifting to the rightmost bit gets lost. And so you can see everything but the rightmost bit slides over, the rightmost bit goes away. And if you look at the decimal versions of these numbers, you can see that we've cut the value in half. And that's what happens when you do a right shift by 1. You cut it in half using integer division by 2. And here again there's a Python operator. This time it's two greater than symbols right next to each other. And so here I'm saying take 15 and shift its binary representation one place to the right. And so we're going to cut it in half using integer division, and we get 7. Here again, you could do a bigger right shift by putting a different value here. You could say shift it by 2 bits to the right or 3 bits, etc.